In today's tutorial, we'll walk through creating a scene that highlights the edges of a box and uses radial symmetry. We're going to be using RayTK version 0.36, so make sure you're using at least that version. Check the video description for a download link for the toolkit. I'm using the Touch Designer 2023 experimental build, but this should all still work the same if you're using one of the 2022 production builds. So you're going to start by dropping the toolkit talks into your project. I like to do that at the root here outside of the main project comp, but you can put it wherever you want. In the experimental build, you'll see some errors on the toolkit where it has some widget compatibility issues in the inspector tool, but other than that, things should still work. We'll be building a scene using a box SDF where we highlight the edges and then also highlight the places where a modulo polar is reflecting it. This came up originally as an example for Chris Northern, who had been looking for alternative approaches to produce images for a pen plotter using RayTK. So first we're going to set up a component to hold our scene, then we're going to set up the renderer and the camera. Then we are going to create the main box and assign color to highlight the edges. And then we're going to add a modulo polar to get radial symmetry. And then we'll take that assigned color for the edges and add to it so that the radial edges are also highlighted. And then we're going to add some basic animation, and that's going to be it. We won't be focusing on materials or lighting in this one, but there are plenty of other RayTK tutorials that cover that stuff. We're going to create our scene comp within a base component, and we're going to do that so that we can add some custom parameters to control the scene. The idea is to create a self-contained component that lets you control the scene and use the rendered output without having to dive into its network unless you want to. While you could do that on the default Project 1 comp, I find that it can be confusing when the scene is also a panel component, which Project 1 is. And it can also be annoying if you want to move the scene around without moving the root of your entire project. So start by creating a base component, and then we're going to rename it to scene, and then we're going to jump inside. We'll start by setting up the renderer. Open the palette using the Alt-R shortcut, and create a RayMarch Render 3D. Then drag out of the first output and create an out top. And we're using an out here so that we can access it from outside the component. So now it comes out stream there and we can use it wherever we want. Select the renderer again and open RayTK's Editor Tools menu with Alt-Shift-R. And then under Add Camera, you're going to choose Look at Camera. We aren't going to be adding any lighting in this one, so we're just going to use the default light that's built into the renderer. Now we can get to setting up the SDF that's going to define our scene. So open the palette and create a box SDF. And then you're going to drag that, connect it to the first input on the renderer. And then I'm just going to look at the rendered output there. And you can do this by, if you are using multiple monitors, you can right-click on that out and say View, and that'll give you a little pop-up window so that you can look at it while you're working in the network editor. To get a better view of it, let's go over to the camera, and we're just going to move the X over by maybe 1 or 2, and then move it up by 1 or 2, maybe 1 over and 2 up. Something like that, so we get kind of a view of the sides and the top a little bit. So now just getting back to our box. All right. The size of the box is going to be a good parameter to expose the scene level, so let's set that up on the parent component. So right-click in an open spot in the network and choose Customize Parent Component. Then in the page field, we're going to type in something like scene and click Add Page. And if the customize dialog does something weird, I guess resize it, seems to fix it. Then we're going to go to the parameters of our box SDF. We're going to take that scale and then drag it into the parameter list here. And then when it pops up the little menu, you can choose bind new par as master. And if you miss that pop-up, you can undo and it will undo the whole thing and you can do it again without any problems. The name scale is somewhat ambiguous, so let's rename it so that it makes more sense when you're looking at it from outside the component. So double click on the name there, and let's choose box size. And it will automatically fix the capitalization for you in the name there. Then on the label, let's do it again, box size. And for this one, we can use a space and a capitalization to make it look nicer. While we have the dialog open, let's also add another parameter for the thickness of the edges. So up at the top here, in the parameter type, we're going to change that to float. And we're going to put in the name thickness, and then just click add par. And for the default, let's set it to maybe 0.2. And then for the range max, we can do like 0.4. So that gives us a nice reasonable range for the slider in the scene parameters. As we go through the scene, I'm going to be using this panel that I've set up on the side here to access the parameters of the parent component. But at home, you probably want to just right-click in the network and choose Open Parent Parameters, and then stick this on another window or something. But I'm putting it into a side panel here just to save screen space. Now that we have the box, it's time to highlight the edges. We're going to be putting this information into the surface color attribute on the SDF. So let's create and assign color, and then insert that after the box SDF. Now we need to create a field that tells it which parts are the edges. This is one of those things that seems like it should be trivial, since with SOPs you can just use like a wireframe SOP. But remember that in ray marching there are no vertices or primitives. Edges are just a property that comes out of the results of the math formulas that define the shapes. So for example, a sphere SDF has no edges or anything even close to an edge, it's just a perfect sphere. Whereas in a SOP, a sphere would be made out of a wireframe. But in ray marching, it's just a function that defines an area. So to identify the edges, we're going to need to set up a field that lines up with where the box is. And what we come up with when we do this is going to work specifically for boxes, but not for other shapes. So there is a hard way to do this, and there is an easy way. So we're going to start with the hard way for educational purposes, but feel free to skip to the next section. First, we'll identify the sides of the box along the x-axis. So I'm going to zoom in a little bit on the camera there. Just go to the camera and set that FOV angle to maybe 45, even lower, 40, so that we get a little bit tighter of a view. All right, let's start by creating a band field. And then we're going to connect that up to the second input on the assign color. For now, we're going to stick to just storing the information about what is and is not an edge as just a single number, so we can change the return type here from vector to float. Later on, we'll take that single number and map it to a range of colors. To make things easy to see while we're working on it, let's set the outside value to something like 0.1, just a little bit above 0, so we can still see the other areas of the shape. So what we have here is a field that's defining where the middle of the box is along that x-axis. So first, we need to switch that to defining the sides. So we're going to take the inside value and the outside value and swap those. Or if you're using a version of the toolkit that has a reverse parameter in here, you can just click that. But this version of the toolkit doesn't have that, so I'm just going to switch this to 0.1 and switch this to 1. And you don't need to do any of the other parts. It's only using just those first two since we set it to floating point instead of vector. Let's also switch off blending so that we get a nice hard dividing edge there. Next, we need to adjust the thickness of that band so that it comes close to the edges. So if you just go to the width here and then increase it up to maybe like 0.8, then we've got a nice indication of where those sides are. So this looks good, but we should check out the scene parameters first. And again, you can do that through open parent parameters. So if we now try doing something like adjusting the box size, you're going to see that the field doesn't know to expand. So it's just, all it's thinking about is a position along the x-axis. It doesn't really know anything about the context in which it's being used. So to do that, we're going to need to set up an expression so that we make sure that the width of that band changes when the box size is different. So for now, I'm just going to set it to like 0.8 or something. So let's go back into our band field, and then in our width, we're going to expand that. So we're going to delete what's there, and then type in parent, parentheses, dot par, dot box size x. So now if we go to the parent component and change the box size, it's doing something, but it's not necessarily what we want here. So if you look at the way that it's slicing that, and you imagine that there was another dividing line right in the middle there, it looks like what we're actually getting are the outer two quarters of it. So you've got, 2 quarters of the area in the middle, and then those outer two. So to make it actually match the width, we're going to need to change that expression a little bit and just say multiply it by 2. So that's just because of a difference in how the band field thinks about width and how boxed SDF thinks about width, which arguably is a bug, but that is just the way it is. So that takes into account the width of the box, but we're only getting super narrow, tiny slices at the ends there. So we need to also take into account that thickness parameter. So in the expression here, we're going to say add on to the end minus parent.par.thickness. Now, if we go over to the parent parameters, we can change that box size, and it's always going to have the same thickness. And we can change the thickness there, and it's always going to fit appropriately based on the size of the box. Now we need to do that for the y-axis and the z-axis as well. So I'm just going to right-click on the connection here after the band field and choose Insert Null. And then I'm actually going to do that a second time. And you should see why momentarily. So then we're going to take this band field and the null after it, copy that, and paste it. Then we can switch over to the second one instead of the first. And then on the band field, we're going to change the axis to y. And then in the expression here, we're going to need to change the box size x to box size y, and then the rest of it can stay the same. So that gives us the top and the bottom. Then we're going to do that again, copy and paste the band field and the null, connect up that third one, go to the band field, change the axis to z, and then the expression, change it to box size z. So now we have the front and the back. By combining these three different fields in different ways, we can identify the edges of the box. So create a combine fields, and we're going to connect up the first one, the x-axis, and the second one, the y-axis. And then let's connect that combined fields to this final null here. So this is right now combining the sides on the x and the top and the bottom to give us this area that's kind of the whole outside area there. But what we want are where those ones overlap. So we're going to change the operation here from add to multiply. So that's giving us those bars along the z-axis. And that color on the inside there is because we had set the band fields up to use an inside value of 0.1 for visibility. So let's just go over to those, and we're going to change that back to 0 for all three of them. So now we've got those 4 bars along that one axis. So let's make a copy of this combined fields, and then we're going to connect the first output to the y here, the second one to the z, and then we connect that up to the null at the end. So now we've got those bars along the x-axis. Then we're going to do this again, copy and paste, and then for this one we're going to connect the first one to the x and then keep the second one connected to the z. So then we look at that, we're going to get those vertical bars. Now we need to combine all 3 of these. So let's select all 3 of those combined fields operators and open the editor tools menu with Alt-Shift-R. And then under combined fields, we're going to choose maximum. So that's going to mean any area where any of these is 1 is going to be 1. And then you connect that up, and there we've got our edge highlights. Now that we went through all those steps to highlight the edges the hard way, we can switch over to doing it the easy way. So fortunately, there is already an operator that finds the edges of a box shape. So let's create a box frame SDF. Then we need to convert this into a field. So we're going to do that by creating an SDF field. And let's connect that up to the second input on the assigned color. So what it's showing us right now is just a raw distance value. So this SDF field takes an SDF and converts it to just a number, which in a sense, an SDF is just a function that produces a number that is treated as distance. So the SDF field allows us to just use that as just a number, and it provides a few different options for ways that it can convert it. So right now we're just seeing the raw distance, which is why it's 0 closest to the box frames, and then like further in it gets larger. And the fact that we're seeing some color on here is just because of the way that the default material is in the renderer. But effectively, this is just like, dark in the edges and then light in the center. So we can change the distance here to inside. Then everything disappears, but that's because we need to fix the sizing of that box frame. So if you go over to that and then just drop all the scale parts down, you'll end up seeing, a little area like that. So we need to get this to match the size of our box SDF. So one option would be to set up an expression on those that references this parameter. But since this parameter is in turn based on one in the scene, it makes more sense to just base this one off of the one in the scene. So let's go over to our box frame SDF, and we're going to expand our scale there. And we can add an expression, parent par.box size x. And then copy that, paste it, do y, copy that, paste it, do z. And so this is a spot where there's a kind of obscure bug that I haven't quite been able to nail down. But the workaround that I found is on the SDF field, just change that offset like just a little bit to 0.002 or something. I'm not sure why that fixes it, but it does seem to. So then we need to set up the thickness of that edge based on our parent thickness parameter. So let's go over to a box frame, and then let's, under the thickness, we're going to add an expression, parent par.thickness. So that is giving us something, but it's really thick compared to what we had if we were doing it the hard way. So it looks like it's actually 4 times the thickness that we had set in the other approach if you did that part. So let's just change this expression here to divide it by 4. Or if you want, you could change the parameter range on that slider and just use, values that are 1/4 the size or something. So now let's go to our parent component, and we can try out different combinations of size settings, the different axes, different thicknesses, and so on. And it's always going to line up correctly. So I'm just going to go back to a size of 1, 0.5, 0.5, and thickness of 0.2, just for now. Next, we're going to add some radial symmetry to the shape. So open the palette and create a modulo polar. And then we're going to insert that between the assigned color and the renderer at the end there. All right, so if you go to the parameters on the mod polar and try changing the pre-rotate, you can kind of see how we now have that 6-point radial symmetry. But we're getting some render glitches in the places where it's crossing over. And if you recall back to the repetition filters intro tutorial, there is an issue there where shape is getting cut off kind of partway through. So easy solution to that is to switch on mirroring. So we just go to mirror type, set that to mirror. So now it's flipping every other slice around that center axis. So we get kind of more of a kaleidoscope effect. So just going to set that pre-rotate back to 0 for now. So now we can add some additional rotation to the shape before it goes into the modulo polar, and that's going to give it kind of a more interesting shape as a result. So let's create a rotate operator, and then we're going to insert that between the assign color and the modulo polar. And now we can try different settings there and do something maybe like, 30, 0, maybe -10 or so. Now we get some sense of the actual three-dimensionality of it. And now it would be helpful to get a little bit wider of a view. So let's go over to the camera and then bump that FOV angle back to maybe 60. So for now though, let's switch off that rotation. We can pop it on later at the end when we're going to be adding some animation. So just disable that for now. So now that we have the modulo polar mirroring and tiling the shape around the z-axis, we've introduced some more areas that you could think of as being edges. So we're going to need to set up another field that marks the edges of where those reflection planes are around the z-axis. And when we do that, let's go over to our camera and just give us a direct head-on view. So we're going to change the position to 0 and 0 for the x and y. All right, so then back on our modulo polar, try toggling the enable button on and off. So it can be a little bit hard to interpret, but what it's doing is taking a kind of wedge-shaped slice and then repeating that around. So makes it a little bit harder to see that it also applies an extra rotation of it, which is why it kind of is at that one is at an angle rather than just being strictly horizontal. But general idea is that it's taking kind of a wedge shaped slice there and then repeating that. So let's switch off the modulo polar for now. So what we need to do is to come up with a field that applies two lines going from the center, out along wherever that cut point is, and then another one going along the other cut edge. So we're going to be storing that information in the surface color attribute like we did earlier. So create another assign color, and we're going to insert that between the rotate and the modulo polar. So this right now is going to just kind of wipe out the edges that we had found earlier, but we can address that later on. So now we just want to focus on just highlighting the edges of that radial slice. So let's create a band field, and then we're going to connect that to the color input on the assign color. Then change the axis here to Y. So this can be a little bit confusing since this kind of looks like it's creating a horizontal line even though we have Y selected. But the axis here is interpreted as meaning it uses the axis position along that axis to decide whether a point is inside or outside the band. So for any point there, it just looks at, how far is it along that line, and the areas that are kind of close to zero are inside, and the areas that are further away from that are outside. And then that's the same anywhere that you do it along the x-axis, which is why we get this line shape kind of appearing across the x-axis. And it's ending there just because that's where the sides of the box are. So now let's make it match the other lines that we had set up in the box's edges. So first, let's switch off blending. And then again, like we did earlier, we're just going to be storing a single number for is this an edge or not, and then we're going to turn that into proper colors later on. So we're going to change the return type on the band field to float. Then we want to connect the thickness of that to our scene's thickness parameter. So you can go into the width here, delete what's there, and an expression parent tar.thickness. And you could also go to the parameters in the parent and say, copy parameter, right click that, and then go onto the parameter and say paste reference. But that does the same thing as just putting in that expression. So then let's go over to our second assigned color there where we're applying it. And so if you try toggling that on and off, you can see that it is producing a line that looks like it's twice as wide as the ones on the box's edges. So we're going to need to divide that in half. So let's go over to the band field here, and then we're just going to add to this expression divided by 2. So now it should match the same width that we had set up on the edges of the box. So the next step is to rotate it to whatever angle the edge of that radial slice is. Since we're only going to be rotating around a single axis, we can just use an axis rotate. So open the palette, create an axis rotate operator. So this is just a simplified, optimized version of the rotate operator. So then we're going to insert that after the band field. So let's then go over to the modulo polar, and we're going to switch that back on. Then on the axis rotate here, we're going to increase the rotation until it starts to disappear. So when it starts getting smaller like that, just stop it. So that's going to happen right at 30 degrees. And the reason that it's kind of going in opposite directions because like that is that we have that mirror setting on in the modular polar. So this gives us one of the two sides of each slice, which is why we're only seeing, 3 of them highlighted here, because we're seeing, one side of this one and then the other side of that one, and so on. So then we need to add another one that's rotated by a different amount so it lines up with the other side there. So let's take this axis rotate, and we're just going to copy and paste that. And then if you connect that up instead of the first one, and adjust the rotate so that it goes to the other edge and does the same thing, you're going to end at -30. So it looks like the second one here is going to be the negative of the first one there. So we can just automate that with a little expression. So go over to our first axis rotate. We can right click on that parameter and choose copy parameter. Go to the second one, right click on that and choose paste reference. And then we can go in and edit the expression, or you could type that out manually and just add a minus at the front. So then we need to combine the two of these. So let's select both of those, open the Editor Tools menu with Alt-Shift-R, and then under Combine Fields, you're going to choose Maximum. So this means places where either of those is 1. So then we connect that up to the assigned color, and now we've got a highlight on both edges of each slice. And that little kind of triangle shape there is because of the shape of the box, that's where the edge is of it. So let's go back over to our modular polar. So what we have set up here works perfectly for 6 repetitions, but try changing the number here to something like 4 or 8, and the lines are no longer going to be correct. So note that because we're using mirroring, we kind of need to have the repetitions at a whole number, or you're going to get stuff being cut off, which is why I'm skipping 7, although it does sort of look somewhat correct, but stick to even numbers. So how do we fix that? So we'll do it by basing the amount of rotation on the properties of this modulo polar, specifically the number of slices that it's taking around the center axis. So let's think about where that 30-degree setting came from. So going back to 6 repetitions. So if you take the 360 degrees around the circle and slice that into 6 even parts, you're going to get 60 degrees. And so that's why the difference between one side and the other side is 60 degrees. Then it's shifting that kind of by half. So instead of 0 to 60, it's -30 to +30. So let's go over to our first axis rotate. Then let's add an expression here. So we're going to do 360 divided by op parentheses quote modulo polar 1 with the P capitalized end quote parentheses par.repetitions with capital R, and then divided by 2. Or you could just simplify it to 180 and then remove that divided by 2 at the end. So now if we go over to the modulo polar, we can change that number of repetitions to different angles, and it's always going to get the lines to match up correctly. And we didn't need to do anything for that second one because it's already set up to be based on the first one, just negated. So let's keep the repetitions back on 6 for now. There's a way that we can optimize this a little bit. Since band field is pretty simple, it's not really necessary, so feel free to skip to the next section if you want. but this is a good example of something that might be counterintuitive with RayTK compared to the rest of Touch Designer. So right now, when the renderer is trying to figure out what the color of the surface should be, it comes to this combine field and asks it for a color about some spot on the box. So the combine fields then asks the first axis rotate, which applies the rotation to that position, and then asks the band field, okay, about that rotated position, is this inside the line or not? Band field does its calculations, comes up with an answer, passes it to axis rotate, which passes it back to combine fields. Then combine fields asks its second input, and that applies different rotation to the coordinates, and then asks the band field about those different rotated coordinates. Does its calculations, comes back, and then combine fields takes those two and then combines the two answers using maximum. With regular Touch Designer operators like SOPs or CHOPs, when you reuse an operator in a network, connecting it to multiple different outputs, that's actually a good thing to do for performance because the data just gets reused instead of having to be recalculated multiple times. But things work differently in RayTK. The band field operator doesn't actually contain any data that the pattern that produces. Each op is basically a machine that answers questions about points in space. So if you ask it about one point, and then you ask it about a different point, it has to do the work twice to come up with a different answer for each of those questions. So given all of that, there is a cheaper option that we can use here instead of doing two rotations and then combining them. And we can do that because these two things are vertically mirrored of each other. So instead, we can just create a reflect operator and then insert that between the first axis rotate and the assigned color. And if you change the direction there to positive y, then we get the same thing. And with a reflect here, it's only passing that question through the band field once. It just applies mirroring to the position before it passes the coordinates along. So you can now delete the second axis rotate and the combined fields if you want. So let's go over to our camera, and then we can just go back to a slightly angled view. So I'm just going to go like maybe 2 over, 2 up. Another optional step is to fix the final rotation of the whole thing. So if we go to the rotate, that's before our assigned color in the modulo polar, and just switch that back on. And then if we go to the camera and just kind of move it a little bit closer to the center, maybe even just straight centered on 0 and 0. It's a little bit hard to see there, but it is placing the kind of symmetry line along the horizontal axis. So we end up with something that's asymmetrical, on left and right. If you like that, just keep it as it is. But if you want it to have it centered kind of along that y-axis instead, we can do that with a change in the modulo polar. So on the modulo polar, we're going to use an expression similar to what we used on that axis rotates. We're going to do 180 divided by me.par.repetitions. And now we've got that centering. And if you change it to another number of repetitions, like 8 or something, it's always going to remain kind of centered across that axis in the middle. We've now successfully highlighted the cut planes of the radial symmetry. And we've also been able to highlight the edges of the original box. But the second assigned color here, where we're applying the edges from the radial symmetry, is basically wiping out the edges that we had found for the box earlier on. So what we need is a way to combine both of those. Fortunately, the assign color provides a way for us to do that using a variable. So select the assign color here and open the editor tools menu with Alt-Shift-R, and then under reference variable, under SDF surface, you're going to go surface color. This variable gives us access to whatever the color was set to before the assign color replaces it. So let's select both the variable reference and the reflect or the combine fields, whichever one you ended up using for that. And open the editor tools with Alt-Shift-R. And under combine fields, we're going to choose maximum. And then we're going to connect that combine fields up to the assign color. So now we have both the highlight of the original box edges as well as wherever those cut planes are from the radial symmetry. Until now, we've been working in monochrome. Even though the surface color attribute is storing it in a 4-part vector, it's just automatically copying that 1 or 0 to all 4 of the parts. So now we can take that and map it into our own color range. So let's create a color ramp field. And then we're going to connect up that combine fields to the coordinate input on it. And then connect that color ramp to the assign color. So now we have 2 different color settings that we can use to control the inside area and the edge area. So these would be good settings to expose as scene level parameters. So let's set that up. So right click in a blank spot in the network, do customize parent component, and then we're going to drag color 1 into the list and choose bind new par as master. And then let's rename this to fill color, and then do the same thing for the label. Then let's go to color 2, drag that in, new par as master, rename it to edge color, and do the same thing in the label. And then we can close the component editor. So feel free to pick whatever color combination you like. There can be some value to having like some amount of brightness in the middle so it doesn't totally disappear, or you could just, completely hide the inner areas or whatever you want to do. So that's it for the elements of the scene. So let's just add some quick animation and then that'll be it. So we're going to do that on the rotate that we're applying before we assign the second color and do modulo polar. So select that rotate operator, open the editor tools with Alt-Shift-R, and then under animate with speed, we're going to choose rotate XYZ. So then let's take this speed generator here. Since we're dealing with angles, we're going to want larger values. So let's change these all to 30, or at least the first 3 parts. It doesn't use the 4th one. So then we have these individual controls for the amount of rotation speed on each axis, and then we have a speed multiplier to kind of control an overall speed for all of the axes. And that's the end. So to recap, we're starting with a box, and then we are using a box frame SDF as a way to create a field that is assigning a color of 1 to the areas around the edges of where that box are. Then we are taking that shape and applying some rotation to it with a little bit of animation. Then we are assigning color to it to highlight to the edges of where the radial symmetry is. And we're doing that by taking a line and then rotating it based on the number of repetitions in the radial symmetry that we're using, so that it's always going to line up with where those edges of the cut plane are. And then finally, we are applying that radial symmetry and then rendering it out using ArrayMarch Render 3D. There are lots of other things that you can do with the scene, like adding materials or lights, or potentially switching on anti-aliasing to clean up some of the edges if your GPU has the power to handle that. Or you could try different kinds of transformations before the modulo polar, so maybe like instead of or in addition to rotation. But it is worth noting that if you do anything there that applies other kinds of symmetry, like if you add a reflect or a mirror octant or something, you're going to need to come up with your own way of creating a field that highlights the edges that that introduces. So the edges that we've set up here work specifically for a box and specifically for a modulo polar. And so anything that you do with a different shape, you're going to have to come up with a different way to highlight the edges. There are some other SDFs where that could work without a whole lot of extra work. So one of those would be like a polyhedron SDF, since it has an option to produce an SDF that's just the edges, kind of similar to how box frame is relative to box SDF. So you could use two polyhedrons and combine them in some way. Anyway, I look forward to seeing what you all do with this, and if you post on social media, use the RayTK hashtag, and at least on Instagram, tag me to make sure that I see it if there's stuff that you want to show off. If you want to support RayTK development, check out my Patreon. You'll get early access to tutorials, exclusive scene downloads, and more. Thanks for watching, and as always, make sure to like and subscribe.